So have you had some time to think about the questions we started this lesson with? Why are some reasons you'd want to work in 3D rather than 2D? Well, simply put, 3D is fun. The world around us is in 3D. It's kind of hard to train your brain to look at a 3D world and turn it into 2D drawings. Makes a lot more sense just to work in 3D if you're working on objects that are three-dimensional. There's also all kinds of cool things we can do when we're working in 3D. We can put parts together to see if they fit. Kind of hard to tell looking at a 2D drawing that's all lines if these parts are actually all going to fit together, you know? But we can do this thing in AutoCAD called virtual prototyping, where we make 3D objects and make sure that they really do fit and they do have the clearances that they need. We can also do this thing called rendering, where we apply materials and light and an environment around our model to create something that looks almost like a photo, and that could be used for mechanical objects. That could also be used to do architectural rendering, all within AutoCAD. Very nice way to present your idea or your concept when it's all rendered out like a professional artist has done it. So there are a lot of reasons why you might want to work in 3D instead of working in 2D. The world coordinate system, do you remember what that was? It's the AutoCAD which way is up system, right? It's the X, Y, and Z and their relationship one to the other. We saw that AutoCAD makes wireframe models, surface models, and solid models. And there were some disadvantages to working with wireframes and surfaces, right? But a solid models behave just like real objects. If you take a block of wood, you can round the corner off with a file. You can do the same thing in AutoCAD. You can round the corner off with an edge fillet. If you want to grind a bevel onto a block of steel, you can do that, right, with a grinder. Well, with AutoCAD, we can do a chamfer edge, and we could put a bevel on something. So the advantage of working with solids, they behave like real objects. We could take a block and drill a hole through it, right? Just like you can in the real world. What's a primitive? We know the primitives are those basic shapes and simple building blocks. And constructive solid geometry is the idea that you can take a complex object and break it into simpler pieces, right? And then create complex things from simple components. The solid history tool lets you go in and edit and sub-select things that you want to change later on. We used the Boolean operation of union and subtract and intersect to do some solid modeling, and we should know what the union and subtract tools do. Alright, so if you're there, you can answer all that. You're doing fantastic. On to page 2. Do we remember what the gizmos do, right? And how the extrude command works? What happens to solid models when you explode them with the explode tool? And then do you remember some of the 2D commands that really do work well in 3D? How do we add a fillet or a chamfer on a solid? What's the best way to do that? And then what properties can you pull out of an AutoCAD 3D solid model? Okay. And then what's a user coordinate system? Well, we know world coordinates are the AutoCAD system for which way is up, which way is X and Y and Z. A user coordinate system is when you specify which way is up, right? The dynamic user coordinate system here let us override AutoCAD's world coordinate system to draw shapes on surfaces that are not on the XY plane, which we're normally limited to, right? And then how can you manipulate the user coordinate system to fit your modeling needs? Well, we learned one way today, and that was using dynamic UCS. Having that turned on while you're modeling will give you the ability to draw in places that you normally can't draw.